Hello viewers, welcome back to my channel. Today we are considering a very important topic in chemistry, which is the calculation of oxidation number in a compound and in a radical. Well, this first video is on the calculation of oxidation number in a radical. I've also made a video on the calculation of oxidation number in a compound. If you would like to check that, you can click on the link below. Then if you like to understand the difference between a compound and a radical, check the link below as well. Also, I made videos on ions and radicals, elements, the symbols of elements, getting the formulas of a compound, that is formation of a compound. You can also check the link below to get this video. And if you are yet to subscribe to my channel, you can, and you would like to, by following my teachings, please press the subscribe button, the notification bell, and the like button. And also share my video to as many as possible. Thank you. So the knowledge of the oxidation number of an element in a radical is important so that we'll be able to name a compound effectively. At the end of this video, you will be able to name a radical, then know the difference between a radical and a compound, and also name a compound, and then calculate the oxidation number of an element in a radical. So let's look at the first radical here, which is the net charge is -1. You will see here that hydrogen has atomic number of 1. So when you arrange it on the shell, the first shell takes just that one. And normally the first shell is supposed to occupy or take a maximum of 2 electrons. But hydrogen has just 1 electron, and that 1 electron is there. So hydrogen will neither give out the one, because it's in need of 1, but it will not give out the only one it has. Neither will it gain, but it can share with another element or with itself. So it is generally known that the oxidation number of hydrogen is +1. Well, actually, when an element gives out or gain, they start having sign on them. So when an element gives out, it becomes positively charged, because they are giving out a negative electron. When they gain electron, which is negative, they become negatively charged. But in this case, hydrogen is special. It has an oxidation number of +1. So we have carbon, the central element. That is the oxidation number of the elements we are going to calculate. So there is a rule in naming a compound or a radical. We start with the first element, then we go to the last element, then we name the central element last. Now, in this case, wherever you see 2, 2 is bi or di. Wherever you see 1, that is mono. Whenever you see 3, we call it tri. Whenever you see 4, you call it tetra. 5 means penta, 6 hepta, then 6 hexa, 7 hepta, octa, nona, and then deca. So in this case now we have just 3 oxygen. So we call it hydrogen trioxo. That's oxygen changed to oxo. Then carbon changed to carbonate, which is a central element. So we don't know the last number there, which is the oxidation number. So when we calculate the oxidation number, we're able to name that radical or a compound. The same is also applicable in a compound effectively. So we have +1 of hydrogen plus this carbon that we don't know. Then oxidation number, or the atomic number of oxygen is 8. We use the atomic number to get the oxidation number. That of oxygen is 8. So when we arrange it, we have 2 on the first shell, 6 on the second shell. We're supposed to take 8. So in that case, it's also short of 2. It gains 2. Instead of giving out 6, it gains 2 to become negatively charged, because it's gaining an electron that is negatively charged. So we have -2, which is the oxidation number of oxygen, but we have 3 atoms of oxygen. So you multiply it by 3. Everything will be equals to -1. Now, so we have +1 plus carbon plus -2 times 3 is -6. Everything is -1. So we have 1 plus 6. Open this bracket, plus times minus is minus. So everything is -1. So we have carbon equals to -1 on this side. Carry -6 to the other side becomes +6. Carry +1 to the other side becomes -1. So we have carbon equals to -1 plus 6. Owing a depth of 1, you have 6. So when you settle the depth, you have 5 left. 5 minus 1 equals to what? 4. So the oxidation number of carbon in this radical is 4. So if you want to name this radical, we name it hydrogen trioxo carbonate 4, which is written in Roman figure Ion. It will end with an ion. Why is it ending with an ion? Because it has a charge, which is -1 on it. A compound is not charged, so a compound is neutral. So we don't end the name of a compound with an ion. So you can try this